Hello there and welcome to the video on straight line graphs. Here we're going to be looking at some coordinates and how you would sketch a graph that's represented by an equation. So let's get the ball rolling then. So a bit of substituting into formulas first. So with each question I give you the x value, you need to plug it into the equation and work out what y needs to be. So pause the video and give this little task a go. Okay, so on the first one, this thing here is the equation, and x is equal to the number 3, and I need to work out what y is. So what I'll do is I'll put 3 in as the x value and work out what y is. So 2 times 3, that's x, that's 6, add 4, that would be 10, so y equals 10. In the next question, it's y equals 3x minus 1, that's the equation, and x is the number minus 6. So I need to do 3 times minus 6, that would be minus 18, take away 1, that would be minus 19. In the next one, y equals minus 2x plus 5, and I have an x value of 3, so replace x with the value 3, and minus 2 times 3 is minus 6, add 5, and I get minus 1. And then for the final one, y equals a half of x plus 3. X is the value minus 4, so a half of minus 4 is minus 2, and then add 3 and I get 1. So there we are, that's the answer for these little questions here. This technique here is going to come in really handy for when we start to draw straight line graphs. Now just a reminder of coordinates. This is how coordinates work. The x-axis is the axis going across. Remember that x is a letter that's across, and it's written as the way that it's written is across. And then y is to the sky. Y is upwards and downwards. And each coordinate marks the location on a grid like this. And you're actually marking the crosshairs of the lines rather than the boxes. Sometimes at primary school what they teach you is that the box is the coordinate. That's not strictly true. It is the point that is the coordinate, not the box. So this point up here is a coordinate of 4 across, 7 up. So the first number is the x-ordinate, the second number is the y-ordinate, and together they make a co-ordinate. So that's what the term ordinate means. It means the value of this part. So the value of the x part is the first number in the coordinate, and the y-ordinate is the second value in the coordinate. And this coordinate here, this coordinate will be written as the first number will be the x value, so we need to go starting from the 0, 0 point, we will go 2 to the right, so that will mean 2 in the first cell in the coordinate, and then 4 upwards, and that will be the y-ordinate, that will be the second number in the coordinate. So the coordinate here is the coordinate 2, 4. The coordinate over here, now this time we have to go left by a certain amount, and that would be minus 3, so that means the first number in this coordinate is minus 3, and then the y-ordinate is 5, and that will be the second number in the coordinate. Moving on to the next little example here, we have one in the bottom left, so that's left first by minus 1, and then down by 2, so that would be minus 2. So it's the first number here that represents that movement left and right from the starting point of 0, 0. We always start from here using coordinates, and then the second number is how much we move up or down by. Positive for going up, negative takes you downwards. Sometimes you'll have a coordinate on the line, and this coordinate here you measure the x1 across first, so that would be 4, but then because it doesn't move up or down by anything from the line that it's on, we say it's the coordinate 4, 0. So it doesn't move up or down by any amount. And the coordinate down here, well, you go across first, and from this starting coordinate here, I don't actually want to go left or right by any value, so that's 0, and then I want to go down by 5, so that'll be minus 5. So there's just a little quick reminder of how coordinates work. Now we're going to start drawing some graphs here now. I'm going to draw the first line with the equation x equals 3. So what I'm going to think of first is some coordinates where the x part of the coordinate is 3. Remember, it's the x part that goes first, the y part that goes second. So I want some coordinates where the first part is 3. So 3, 1, 3, 2, 3, 3, 3, 4. So all of these coordinates here have an x part of 3. Now let's plot these points. So it's going to be 3 across, 1 up. Start from the beginning again at 0, 0, 3 across, 2 up. Start from the beginning again at 0, 0, 3 across, 3 up. Start from the beginning again, 3 across, 4 up. I could even go down by some, so I could go 3 minus 5. 3 across, down 5. And you can see what would happen here. I don't need to do every single coordinate here, but what will happen is we'll get a perfect straight line that will come downwards at the x coordinate of 3. So this equation here represents this line, or we can create this line just from this equation. It's the equation where the x part of the coordinate is always 3. So this x and y is always referring to the numbers in the coordinates. On to the next one, x equals minus 5. So again, I want a minus 5 to appear in the x position of the coordinate. So maybe something like minus 5, 1, minus 5, 2, minus 5, 3. You can see here that with all these coordinates, minus 5 is appearing in the x position because I want to draw the curve x equals minus 5, 6, for example. Maybe some negative ones down, minus 5, minus 4, minus 5, minus 20. It won't fit on the graph, but it would go down to minus 20 as well. So let's plot some of these coordinates. Minus 5, well, I get to minus 4, I could go one more to the left to get to minus 5, and then 1, so here, minus 5, 2, start from the beginning again, minus 5, 3, start from the beginning again, minus 5, 6, start from the beginning again, minus 5, minus 4, and minus 5, minus 20, that'd be way off the scale. So here is the straight line for this equation. This equation here is the curve x equals minus 5, or the straight line minus 5. Let's do something a bit different now. Maybe y equals 4. So remember that it's this time the y part of the coordinate is the second number in the coordinate. So as long as the second number in the coordinate's 4, I'm happy days. So it might be 1, 4. It might be 2, 4. It might be 3, 4. It might be 4, 4. In all of these coordinates, the second number in the coordinate is 4 because I want to draw the curve y equals 4. So let's draw these coordinates. Start from the centre, 1 to the right, 4 up. Start from the centre again, 2 to the right, 4 up. Start from the centre again, 3 to the right, 4 up. Start from the centre again, 4 to the right, 4 up. And you can see what would happen here. It would form a horizontal line for y equals 4. When you're drawing these graphs, once you've drawn a straight line graph, write the equation at the end of the graph and it just looks really nice and neat. Let's move on to another one, y equals minus 2. So remember, y is the second part of the coordinate, so I want the second part of the coordinate to equal minus 2. So maybe I might start at something like 5 minus 2, 4 minus 2, 1, so minus 1 minus 2, maybe something like even 0 minus 2. Doesn't matter what number's the first ordinate, as long as the second ordinate, the y ordinate, is minus 2. So let's draw these positions here. So start at the centre, 5 minus 2. Start from the centre again, 4 minus 2. Start from the centre again, minus 1 minus 2. Start from the centre again, 0 to the left or right, down by 2. And we'll get this line here. This is the line y equals minus 2. All of these coordinates, every single coordinate along here will have a y part of minus 2. Take this coordinate here, for example. This coordinate here would be minus 3, minus 2, because I have to go left by 3, down by 2. So it would be minus 3, minus 2, where the y part of this coordinate is minus 2. So hopefully that's made sense there. It's always the x part first, then the y part second. Now, we're starting to get onto some more difficult equations here where the x part of the coordinate and the y part of the coordinate are equal to each other. So thinking about what the coordinates are here, x is the first number, y is the second number. As long as the y number is equal to the x number, then that is a coordinate that will appear on my graph. So maybe something like 4, 4. In this coordinate, the x part of the coordinate, this one here, is exactly equal to the y part of the coordinate, this coordinate here. So 4, 4 will be a coordinate that will appear on this line. 3, 3 will also be a coordinate that will appear on this line because the x ordinate is equivalent to the y ordinate. That's the rule for generating these numbers in the coordinates here. This is kind of like the rule for generating coordinates. Rule for generating coordinates. So 3, 3 would be a number, so a coordinate on this line. 2, 2 as well, as long as the first number is the same as the second number. Even 0, 0, yeah, it sits as the number 0, but it's still x equals y. Minus 1 would also be one on the curve, on the line. So it would be all of these coordinates down here. And you can see here that we will now get a diagonal line. So the first of many diagonals that we'll see here, this is the line y equals x. And if you've got a ruler, please make sure you've used a ruler to sketch this graph here. It's a bit difficult with my stylus on this tablet, so make sure you use a ruler, please. What about this one here then? This is the new rule for generating coordinates. So let's just have a little think then. If x is the value 1, then use the rule to work out what the y coordinate will be. So x is the number 1, so 2 times the number 1 will be 2, so y equals 2. And by using this process, you can create coordinates. So the x part is 1, the y part is 2. Inside a coordinate, it's the x part first, the y part second, so it will be the coordinate 1, 2. So I'll plot that as my first coordinate. Start from the centre, 1 across, 2 up. Let's do another one. Let's choose another easy x number, 2. Let's plug it into the rule for generating coordinates. X number is 2 this time. 2 times 2 is 4, so y is the number 4. And then from these two numbers here, I can generate the coordinate 2, 4. So it's 2 across, 4 up. And what you might be able to do when you get really good at this is you might be able to do it in your head. I might do next x equals 3. Plug 3, the number 3 in as x into this equation, and I'll get 2 times 3 is 6. Y will therefore be the number 6. So therefore the next coordinate will be 3, 6, because x is 3, y is 6, and it goes x part then y part next. So 3, 6. Another one, x equals 4. Maybe you might want to try this in your head before I can get to the answer. 4, we take the number 4 and we put it into the x position in the equation. 2 times 4 is 8, so the next coordinate would be 8. So the total coordinate, x part will be 4, y part will be 8, so it would be 4, 8. Let's try an even easier x number. And what numbers could be easier than 1, 2, 3, or 4? Well, 0. 0 is actually the easiest x number that you could possibly think of. So it's just 2 times 0. 2 times 0 is 0, so y is equal to 0. So the coordinate here is going to be 0, 0. And let's just do one negative, just for luck. Minus 1. Now, 2 times minus 1, put the minus 1 in the x position. 2 times minus 1 is minus 2, so y equals minus 2. So therefore, it's the coordinate minus 1, minus 2. And what you're probably thinking is, where did I get this list of numbers from? Well, actually, I just decided to use easy x coordinates. I decided to use the easiest of the coordinates I could think of, and then work out what the y coordinates would be. Don't necessarily have to use these x values in this order every time, but it's a good suggestion, maybe. Once you've got this with a ruler, connect all your points together. And there we are. This is the line y equals 2x. And what you might have spotted is that on the y coordinates, you may have spotted a pattern. It goes up by 2 each time you go onto the next coordinate. As you move up the x numbers, the y values add 2. And what's happening here is that as the x number gets bigger by 1, the y value is getting bigger by 2 each time. And we'll come to that later on. This value of 2 here, the number of jumps the y coordinate is going up by each time, is known as the gradient. So in this question here, the gradient is 2. Let's have a go at another question now. Y equals 2x plus 3 this time. So it's basically the same as the question before, but then just add on 3. So when x equals 1, you put... where did x equals 1 come from? I've just thought of it. I've just thought of pick an easy x number to put into this equation. And 1 seems like a pretty easy number to me. So I've taken the number x equals 1, and I'll put it into this formula that helps me work out the coordinates. 2 times 1 is 2, add 3 is 5. So the next coordinate here will be 1, 5. 1 across, 5 up. Can we think of an easier x number? Well, 0. 0 is a pretty easy x number. So y equals 2 times the number 0 that I've just thought of, trying to choose easy x values. 2 times 0 is 0, add 3, you get 3. So this coordinate here will be 0, 3. So 0, 3. Another easy-ish x number, maybe you use the x number 2. 2 times 2 is 4, add 3, you get 7. So the next coordinate will be 2, 7. 2 across, 7 up. And maybe we'll just do one negative one just for luck. Minus 1. So now plug minus 1 into the equation. 2 times minus 1, that's minus 2. Add the 3 and you get 1. So the next coordinate will be minus 1, 1. So left by 1, up by 1. This will be the next coordinate. And what you'll notice here is that it's another similar diagonal that looks just like that. And again, on this curve, we seem to be going up by 2 on the y-axis each time we move up 1 on the x-axis again. So the gradient here again is the value 2. But it's a little bit different. Let me just write that out. It's a little bit different to the curve before. If you compare this answer and this answer, then the difference between this answer and this answer is that this answer here has just been moved up by 3 compared to this previous answer here. You can see that this coordinate here is at 1, 2, and on this graph here is at 1, 5. So every coordinate has moved up by 3 for this curve here. And that's what this part of the equation is doing. It moves the curve up or down, because it could be a negative number, by however much you want it to move up or down by. And you'll also notice that it cuts the y-axis at that exact number 3. Why is that? Well, because at the point that it cuts the y-axis, it hasn't moved left or right by anything, so the x value is 0. And whenever you times whatever your gradient number is by 0, it will just effectively disappear. It becomes 0. And so you'll just then have the 3 to move up by. Let's just do a few more of these drawing graphs by the coordinates. So let's pick x equals 1. So then y will equal 1 minus 2 is minus 1. So therefore we get the coordinate 1 minus 1. Let's pick the x number of 2, another easy x number. Y this time would be 2 minus 2 is 0. So the next coordinate would be 2, 0. The next coordinate we'll choose maybe 3. I'm just picking easy x numbers here that I can use to make my coordinates. 3 minus 2 is 1, so the next one will be 3, 1. Let's maybe choose x equals 0. That's a pretty easy x value. So 0 minus 2 is minus 2. That would be another coordinate. And then just do one more negative one just for luck. Minus 1 minus 2, that would be minus 3. So let's plot these coordinates. 1 across minus 1 up, or move 1 down. 2 across, 0 down, so that would be on the line. 3 across, 1 up. 0 across, 2 down. -1 and -3. You can see what will happen here. It will form a nice diagonal going down like that. And we've worked out 5 coordinates here, and they all should be in line. If you ever get 5 coordinates where they're kind of off a little bit, then just check the coordinates that you've done the correct calculation. 5 is a pretty safe number. If you've done less than 5, you might risk it actually being in the wrong direction, whereas 5 is a safe number to make your straight line with. And the next one, 3x minus 2, so we'll do x equals 1. So times 3 by the value 1 that we've just used here is an easy x number. 3 minus 2 is 1, so that'd be 1, 1. Next one would be 2. 3 times 2 is 6, minus 2 is 4, so that'd be 2, 4. X equals 3. 3 times 3 is 9, minus 2 is 7, so the next one would be 3, 7. Let's just choose the easiest x number of them all, 0. 0 times 3 is 0, minus 2, that would be minus 2. Let's choose one negative number just for luck. Y equals 3 times minus 1, that's minus 3. Take away another 2, that would be minus 5. So we'll now plot these coordinates here. So that would be 1, 1, 2, 4, 3, 7, 0, minus 2, and minus 1, minus 5. And we'll now connect those in a line and just make sure they zoom off in the opposite direction. And there we are. So we'll draw y equals 3x minus 2 to just label the graph. And one final one before we have a look at the general rules for drawing straight line graphs. If we have x equals 1, then y is going to equal 1 times a half is a half. Add 5 will be 5.5. So the first coordinate will be 1, 5.5. X equals 2. 2 times a half is 1. Add 5, you get 6. So that would be 2, 6. 3. So it'll be 3 times a half will be 1.5. Add 5, you get 6.5. So that would be 3, 6.5. When x is equal to 0, we'll get 0 times a half is just 0. Add 5, you get 5. So that would be 0, 0, 5. And let's just do a negative one just for luck. Y will equal a half times minus 1, that would be minus a half, minus 0.5. Add 5, you get 4.5. So that would be minus 1, 4.5. And let's plot those coordinates. We'll start up at 5, then 1, 5.5, 2, 6, 3, 6.5, minus 1, 4.5 here. So now we can spot the pattern that it's going up by a half each time. Lovely, there we are. And that is the graph y equals a half x plus 5. Okay, so that took us quite a while to draw those graphs. Let's see if we can spot any shortcuts and spot some patterns in how we might draw straight line graphs in the future. So I've drawn here 3 graphs, y equals 2x plus 3, that's the red one. The blue one is y equals 2x plus 1, and y equals 2x minus 2 is the green one. Now what you'd probably be able to spot here is they all have the same steepness to the graph. They all have a steepness of 2. So the lines have a steepness of 2, and we call this the gradient of 2. And you can see where this appears in the equation, the x value, so the coefficient of x, and what coefficient means, it's the number that's in front of x is always 2 for these equations. But the difference between these equations is that they start at different points on the y-axis, depending upon what number you add or subtract at the end. We call this the Y-intercept. So you can see here the red line starts at the number 3 on the y-axis because we have to add 3 on the end of the equation. On the blue line it starts at 1 because I'm adding 1 onto the end of the equation on the blue one, and on the green one it starts down at -2 because I'm taking away 2 at the end of the equation. What these adds and subtractions are doing is effectively moving the whole line either up 1, up 3, or down 2 from your bog standard y equals 2x graph. Okay, so the number that's in front of x is the gradient, and the number that's added on to the end is where it starts on the y-axis. And we can show you some few more examples here. We've got a red graph of 3x plus 3. Blue is y equals 3x plus nothing. We're not adding or subtracting anything here. And y equals 3x minus 5. This graph has a steepness of 3, or a gradient of 3. But it starts at different points depending upon what we add or subtract on the end. Here we start at 3 because we add on 3 to the red graph. This blue graph starts at 0 because we're not adding or subtracting anything. And minus 5 will be down here because I'm taking away 5 from the equation, from all of the coordinates on the equation. And we could even have some negative directing graphs. So this is where we have a negative gradient. This gradient here would be minus x. So this has a steepness of -1. And what I mean by a steepness of -1 is that whenever you take a coordinate and go right and then down, it's down by 1 or up by -1. So we have a gradient of -1. The lines start at different points depending upon the numbers you add or subtract. So for the red graph, I've added on 2. For the blue graph, I've added on nothing. And for the green graph, I've taken away 3 because I'm starting at -3. This number here is what we call the y-intercept. And we could even have some fractional gradients as well, where they're nice and flat. So we've got half x plus 2 because it starts at 2, half x plus 0 because it doesn't have anything added or subtracted, and y equals half x minus 3 because we are taking away 3 from each of the coordinates to get down to the green graph. So what does the half mean? Well, it means take a graph from any coordinate, and when you increase the coordinate on the x-axis by 1, you increase the y-axis by a half. So I've gone up by a half here from 1 to 1.5 on the scale here. So the steepness, or the gradient of this graph, is a half, and the y-intercept will change where the graph intercepts on the y-axis. So the steepness of the graph is called the gradient. You need to be confident in using that word gradient and be familiar when other people refer to the word gradient. It measures how much you go up by every time you go right by 1. The value is always the number that goes in front of x in the equation, the gradient number. And the graph will also intersect the y-axis depending upon what number you add or subtract at the end of the equation. We can quickly draw graphs using these general rules. So when I look at an equation now, what I spot is that I'm going to have two numbers that are important on my graph. The first number that goes in front of x is how steep the graph is. And when I move on to the next coordinate, I'm going to move 3 up. And the +1 is where I'm going to start on the y-axis. So let's start by drawing this graph then. So the first thing I do is I start at the number 1 on the y-axis. So the first point is going to be this point here. And then when I move on to the next coordinate, I'm going to move up by 3. Move on to the next coordinate, up by 3. Move on to the next coordinate, up by 3. And I've gone off the scale here. I could also move back to the next backwards a coordinate, and I'll have to move down by 3 in that case. Move back a coordinate, I'll move down by that 3. Move back a coordinate and move down by that 3. And that's a much quicker way of drawing straight lines, by spotting that you start at the y-intercept and you move up or down by 3, depending upon whether you're going in the positive direction or the negative direction. Move on to the next one. This time I'm going to start down at -3 on the y-axis. And then when I move on to the next coordinate, I'll add on 2 onto the y coordinate. So I'll move onto the next coordinate right by 1 and then up by 2. Right by 1, up by 2. And it's always right by 1, right by 1, up by 2. Right by 1, up by 2. Right by 1, up by 2. I could move backwards, but I'd have to move down by 2. Backwards, down by 2. Backwards, down by 2. Connect all of those points together, and you've got a lovely straight line graph there. Y equals 2x minus 3. Move on to the next graph. I'll start at 2 for this graph here on the Y-intercept. And this time the gradient is a number that's disappeared, but when I just write x, I'm actually referring to 1x. 1x plus 2. So when I move on to the next coordinate, I'll move up by 1. Next coordinate, up by 1. Next coordinate, up by 1. Next coordinate, up by 1. Backwards, but I have to move down by 1. Backwards, but down by 1. Backwards, but down by 1. Backwards, but down by 1. And then connect up all your points with a straight ruler, and there we are. Moving on to the next one. Start at 5 up on the y-axis. So starting at 5 here on the y-axis, always on this y-axis line here. And this time, actually, instead of moving up by a certain amount, I'm going to move down by a certain amount. Or effectively, you could think of it as moving up by minus 3. And when you move up by a negative number, you're moving down. So move on to the next coordinate, down by 3. Move on to the next coordinate, down by 3. Move on to the next coordinate, down by 3. Move on to the next coordinate, down by 3. And we could move backwards, but we'd have to do the opposite of moving down, which would be moving up by 3. And there we are. That's the graph of y equals minus 3x plus 5. And you'll probably notice that when you have a negative x number, it's a downward sloping graph. Moving on to the next one, start at the number 2. And this time we're going to move on to the next coordinate, but only move up by a half. So next coordinate, up by a half. 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 Back, but down 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 by a half. And that flat line there, well not flat, but more flatter line, is y equals a half x plus 2. Okay, so now it's your turn to have a go at some questions from the worksheet in the description of the video, so make sure you pause the video, go into the worksheet in the description below. I even think on the second sheet of the worksheet there are 9 graphs for you to just practice with when you have a go at the questions, the 8 questions on the worksheet. So yeah, pause the video and give those questions a go. Come back to the video and we'll go through the answers. So let's now do so. Y equals 2x plus 4. So what I need you to be able to do in these questions is just really quickly draw them using the gradient Y-intercept method. And the Y-intercept method is to just start at 4 on the y-axis and then use the gradient value of 2. And this means move on to the next coordinate, up by 2. Move on to the next coordinate, up by 2. Move backwards, but that would mean move down by 2. Move backwards, but down by 2. Move backwards, but down by 2. Move backwards, but down by 2. And connect them up. Once you've done the question, write down the equation of the graph next to it so that whoever's coming to mark it has a really easy job. Move on to the next one, so it would be move down to minus 1 on the y-axis, and then it's move on to the next coordinate, up by 3. Move on to the next x coordinate, up by 3. Move on to the next coordinate, up by 3. Move backwards, but that will mean move down by 3. Move backwards, but down by 3. So that will be what the equation of the line looks like. Y equals 3x minus 1. Move on to the next one, and it doesn't have anything added or subtracted at the end of this equation. So that means I'll move up or down by nothing. I'll start at the origin, the center of the axes. And this time it's move on to the next coordinate, up by 4. Move on to the next coordinate, up by 4. Move backwards but down by 4. Move backwards but down by 4. So this graph here is pretty steep. It's a gradient of 4 where you move right by 1 and up by 4 each time you move on to the next coordinate. Next one will be starting up at 5, and then it's right by 1, up by 3. Then we haven't got any more space, so I suppose we should go backwards. Backwards by 1, down by 3. 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 And there we have it. Voila, the next line. That is the line y equals 3x plus 5. Make sure you write the equation of the line next to the line. Start up at 7 this time. And then it's a downwards graph this time because it's got a negative x number. So it's going to be right by 1, down by 2. Move on, down by 2. Move on to the next coordinate, down by 2. Move on to the next coordinate, down by 2. Move backwards and up by 2 to do the opposite. And there we have it. It's the line y equals minus 2x, add 7. Move on to the next curve. We start up at the number 3. And then it's right by 1, up by a half. Move 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 right by 1, up by a half. We could go backwards, but that would mean doing the opposite and moving down by 1, down by half, down by half, down by half, down by half. And there we have it. That's y equals a half x, add 3. Move on to the next one. Thirds this time. This will be pretty tricky. So up to the number 2, and then it will be right by 1, up by a third, right by 1, up by a third, right by 1, up by a third. And once you've done 3/3, you should have moved up by 1 on the y-axis. Right by 1, up by a third, right by 1, up by a third. Go back to the starting coordinate and move back by 1, down by a third, back by 1, down by a third, back by 1, down by a third. And once you've gone backwards by 3, you should have gone downwards by 1. Just like that. So you can see the smaller the fraction, the flatter the line is getting. Y equals a third x plus 2. And the next one will be start up at the number 6. And then it's going to be right by 1. And because it's a negative x number, it will be down by 3. Right by 1 or onto the next coordinate, down by 3. Onto the next coordinate, down by 3. Onto the next coordinate, down by 3. And then backwards by 1, up by 3. And connect your curve together. Y equals minus 3x plus 6. Okay, and there we are. That's all of the questions we're going to go through in this video then. So hopefully you've now learnt how you can quickly draw straight line graphs given the equation. You do a two-step technique. You start at the number that's being added or subtracted on at the end, and then you go up or down by the number that's in front of x, the gradient. And hopefully you've become familiar with those two words now of y-intercept and gradient. Lovely. Thanks very much for watching.